So, large language models, they're incredibly powerful. We all know that. But right out of the box, they have some pretty major limitations. To make them genuinely useful for you or your business, we've got to connect them to our own data and shape them for very specific jobs. And in this explainer, we're going to break down the two main ways you can do exactly that: RAG and fine-tuning.
Okay, so picture this. You hire an absolute genius. This person has read almost every book, every article, every paper published up until about a year ago. They're brilliant, but there's a huge catch. They have no idea what your company has been working on, they can't see your latest sales figures, and they're completely in the dark about everything that's happened in the world recently. Well, that's pretty much the exact problem we have with off-the-shelf pre-trained LLMs.
Right, so this whole genius with amnesia problem, it creates some pretty significant blind spots. While these models are amazing at general knowledge, they're basically operating in a total vacuum when it comes to your specific world, your data, your needs.
And here are those blind spots, laid out. First, the model's knowledge is literally frozen in time. It's stuck in the past, which makes it totally useless for questions about what happened last week, let alone this morning. It's also completely locked out of your private data. You know, your internal wikis, your customer support chats, all that good stuff. And what do you get? Well, you get really generic answers when you need sharp, specific ones. And even worse, the model might just start making things up. That's what we call a hallucination.
So that brings us to the big question. If the standard model isn't cutting it, how do we upgrade it? How do we give it the knowledge it's missing? Turns out there are two main paths we can go down, and they both tackle the problem in a completely different way. Let's dig into the first one.
So our first method is called Retrieval-Augmented Generation, or just RAG for short. You know, the best way to think about RAG is like giving our AI genius an open book exam. Instead of trying to perform brain surgery on it, we're just handing it a really good set of cheat sheets or reference notes to use while it's answering our questions. And that's the absolute key here. RAG doesn't actually change the LLM itself. It's a system that works alongside it. What it does is it goes and fetches the most relevant, up-to-date info from a source that you provide, say your company's document library, and it gives that fresh context to the model right along with your question.
And this flow shows you exactly how it works. It's actually pretty elegant. You ask a question, the RAG system immediately springs into action, searching your private database for the most relevant documents or snippets of text. Then, it bundles those findings together with your original question and hands the whole package over to the LLM. Now, the model has all this specific fact-based context to work with, and it can give you an answer that's actually grounded in your data.
And the benefits of doing it this way are, well, they're huge. You can keep all the information current just by updating your documents. No need for costly, time-consuming retraining of the model. It dramatically cuts down on the risk of the model just making stuff up, because its answers are based on the real information you gave it. And maybe best of all, you can actually trace the answer back to the source document it came from, which is absolutely critical for checking its work.
Okay, so let's shift gears to our second strategy. If RAG is the open book exam, fine-tuning is more like sending our AI genius to a highly specialized grad school program. We're not just giving it notes anymore. This time, we are fundamentally changing how its brain works to teach it a brand new skill or a very specific style. This visual nails the core concept. We take a big, powerful, general-purpose model, and we continue its training. But this time, we do it with a much smaller, hand-picked dataset of examples that are perfect for our specific task. This whole process actually adjusts the model's internal wiring, its core logic, making it an expert in one very specific thing, whether that's analyzing legal contracts or writing in your company's unique brand voice.
Now, there are a couple of different flavors of this. You've got your standard fine-tuning, which is all about learning by example. You know, you show it thousands of customer reviews labeled happy or unhappy, and eventually it learns to tell the difference. But then there's instruction fine-tuning, which is a step up. You actually teach the model to follow specific commands, like summarize this article in 5 bullet points. And that gives you way more precise control over what it does and how it does it.
But, and you probably knew a but was coming, right? This kind of deep, intense specialization, it comes with some serious risks. When you train a model so hard on one specific thing, you can run into a pretty nasty problem.
And it has this amazing name, catastrophic forgetting. I mean, it sounds dramatic because it is dramatic. As the model adjusts all its internal logic to become an expert at your new task, it can accidentally overwrite or just forget some of the massive amount of general knowledge it learned in its first round of training. So you might end up creating a world-class expert on medical billing codes that suddenly can't remember who the first president was. Thankfully, some really clever techniques have been developed to stop this from happening. One way is multitask fine-tuning. You basically train the model on your special task and some general tasks at the same time to keep its skills sharp all around. But an even more popular method is called parameter-efficient fine-tuning, or PFT. With PFT, you freeze the original model's massive core brain, protecting all that general knowledge. Then, you just add a few small new layers on top and only train those. It's like giving our genius a new, specialized notebook instead of trying to rewrite their entire memory.
Okay, so we've covered how to make these models smarter, and we've talked about some of the technical traps you can fall into. But honestly, the biggest risks aren't always technical. With this much power, you have to be responsible. Whichever path you choose, RAG or fine-tuning, you absolutely need an ethical compass to guide the way. And this isn't just a nice-to-have, it's a core part of the job.
This first principle is so fundamental. It's basically saying, don't build in a vacuum. If you're building an AI tool to help patients understand their medical records, you should probably talk to doctors, nurses, and, actual patients right from the very beginning. Not just build the whole thing and then ask them what they think at the end. Their insights will make the tool better and safer.
This next point is really all about self-awareness. When you fine-tune a model, you're the one choosing the data. That choice fundamentally shapes the model's worldview and how it behaves. So this is just a reminder to be really conscious of that power and to think critically about what perspective you're teaching the model to adopt.
And this one might sound a little formal, but it's really just about treating responsible development with the same seriousness as any other part of engineering. You have code reviews to check for quality, right? You have security checks to look for vulnerabilities. Well, this just says you should also have a structured process to make sure you're building things thoughtfully and not cutting corners that could cause real harm down the road.
And this table here shows you exactly how these big ideas translate into day-to-day actions. Let's just take data collection. The don't column shows all the risky shortcuts, like assuming data is just a raw resource you can take. The do column shows you the professional, responsible alternative. Document where your data comes from. Respect the wishes of creators, like those robots.txt files that ask not to be scraped. And just be transparent about what your data is and what it isn't.
Okay, we have covered a ton of ground: the what, the how, and the why. So let's pull it all together into a practical playbook that can help you decide which one of these powerful techniques is the right tool for your job.
This right here, this is your decision guide. You're going to lean towards RAG when your main goal is to pump factual, up-to-the-minute knowledge into the model's answers. It is perfect for building a Q&A bot over your internal documents. You're going to choose fine-tuning when you need to change the model's actual behavior, its style, its tone, or to teach it an entirely new skill. And hey, remember, it's not always an either-or choice. A lot of the most advanced systems actually use both. They fine-tune a model to get the right personality, and then they use RAG to feed it real-time facts.
And really, that's the ultimate takeaway from all of this. Whether you're giving an AI notes with RAG or sending it to grad school with fine-tuning, the goal isn't just to build something that's powerful. It's to build something that works for people, safely and thoughtfully. Because the best AI systems of the future won't be measured by their power alone, but by their responsibility.